Welcome to NSMO, the National Science and Mathematics Olympiad. Today we are going to learn about an isotopes. Isotopes are atoms of the same element that have the same number of protons, which means they have the same atomic number, but they differ in the number of neutrons. Because the number of a neutron is different, isotopes of the same element have different mass numbers and therefore different atomic masses. Even though isotopes have different masses, they are still the same element because the number of protons does not change. Example 1. Isotopes of carbon. Carbon has an atomic number of 6, so every carbon atom has 6 protons. Carbon have several isotopes including carbon 12, carbon 13, and carbon 14. Carbon 12 has 6 protons and 6 neutrons. Carbon 13 has 6 protons and 7 neutrons. Carbon 14 has 6 protons and 8 neutrons. All three are carbon atoms because they have the same number of protons, but they have different masses because the number of neutrons is different. Let's move to example number 2, the isotopes of hydrogen. Hydrogen has an atomic number of 1, so every hydrogen atom has 1 proton. Hydrogen has 3 main isotopes. Protonium has 1 proton and 0 neutron. Deuterium has 1 proton and 1 neutron. Tritium has 1 proton and 2 neutrons. These are all hydrogen atoms, but their masses number are different because the number of neutrons is different. Exercise. Determine the number of protons, neutrons, and electrons, as well as atomic number and mass number for the following isotopes of the element lithium. Now let us determine the properties of 2 isotopes of lithium, lithium-6 and lithium-7. Lithium has an atomic number of 3, so it always has 3 protons and 3 electrons in neutral atom. For lithium-6, mass number is 6, number of a neutron 6 minus 3 equals 3 neutron. For lithium-7, mass number 7, number of a neutron 7 minus 3 equal 4. Both isotopes are lithium because they have the same number of protons, but they differ in the number of neutrons. What is meant by atomic mass and how is it calculated? And why is the average atomic mass not an integer? Atomic mass. The atomic mass of an element is the average mass of its naturally occurring isotopes. To calculate the atomic mass, we multiply the mass of each isotope by its natural abundance, then add the results together. Because isotopes have different masses, the average atomic mass is usually not a whole number. The atomic mass of lithium is 6.94 because lithium exists in nature as a mixture of isotopes, not just one type of atom. Lithium has two main natural isotopes. Lithium-6 with mass 6 AMU. The natural abundance is about 7.5%. Lithium-7 with a mass equal 7 AMU. The natural abundance 92.5. Atomic mass is the weight average. The atomic mass shown on the periodic table is the average mass of the naturally occurring isotopes, taking their abundance into account. So, for lithium, we have to multiply 6 times 0.0075 plus 7 times 0.925 equal 6.925 or 694. The atomic mass of lithium is 6.94 because it is the weight average of lithium-6 and lithium-7 based on their natural abundance. Let's solve this exercise. Atomic mass of copper. Copper 63 with a mass of 62.93 AMU and an abundance of 69.2. Copper 65 with a mass of 64.928 AMU and an abundance of 30.8. The atomic mass of copper is calculated as 69.93 times 0.692 plus 64.928 times 0.308. We will get 63.55 AMU. So the atomic mass of copper is 63.55. Thank you, with my best wishes for success.